This is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. Okay. The topic is Definitions and Terminology of Thermal Energy Based Processes. Okay. So, under the content beyond the syllabus for the unconventional machining, we are discussing the electrical energy based process. Okay. First one, define electrical discharge machine. Okay. Right. EDM is the controlled erosion of electrically conductive materials by the initiation of rapid repetitive spark discharge between the electrode tool to the cathode and work to anode, separated by a small gap kept in the path of dielectric medium. This process also called spark erosion. Okay, so EDM is the controlled erosion of electrically conductive materials by the initiation of rapid and repetitive spark discharge between the electrode tool to the cathode and work to anode, separated by a small gap kept in the path of dielectric medium. This process is also called spark erosion. Okay. What are the functions of dielectric fluid used in EDM? First one, it acts as an insulating medium. It cools the spark region and helps in keeping the tool and workpiece cool. Okay. Third one, it maintains a constant resistance across the gap. Okay. Fourth one, it carries away the eroded metal particles. Okay. It remains electrically non-conducting until the required breakdown voltage has been reached. Okay. So these are the functions of the dielectric fluid used in electro discharge machine. Okay. So in short, it is EDM. Okay. Right. What are the basic requirements of dielectric fluid used in EDM? Okay. Stable dielectric strength. Second one, it should have optimum viscosity. Third one, it should have high flash point. Fourth one, it should be chemically stable at high temperature and neutral. Okay. And fifth one, it should not emit toxic vapors. Okay. So obviously, we all know, because of any chemical reaction, the toxic vapors will come out. But in electro discharge machining, when we use dielectric fluid medium, it should not emit toxic vapors. So we have to select such kind of dielectric fluid mediums. Okay. So these are the basic requirements of dielectric fluid used in EDM. Okay. Right. What is the dielectric fluids commonly used in EDM? Okay. So sorry. What are the dielectric fluids? Okay. Right. First one, petroleum based hydrocarbon fluids. Second one, paraffin, white sprite, transformer oil. Okay. Third one, kerosene, mineral oil. Fourth one, ethylene glycol and water miscible compounds. Okay. Right. So these are the dielectric fluids commonly used in electro discharge machining. Okay. Right. What are the prime requirements of tool material in electro discharge machining? It should be electrically conductive. It should have good machinability. It should have low erosion rate. It should have low electrical resistance. Melting point of tool should be high. Okay, right. Let me reiterate these important points. Why? Because these are the prime requirements of tool material in electro discharge machining. Okay, it should be electrically conductive. Okay, it should be electrically conductive. It should have good machinability. It should have low erosion rate. Okay, it should have low electrical resistance. Okay, and melting point of the tool should be high. Okay, the tool should not be melt at the low temperatures. Right. So these are the prime requirements of the tool material used in electro discharge machine. Okay, right. What is the effect of capacitance in EDM? Right. Increasing the capacitance causes the discharge to increase and increase both the peak current and discharge time. Okay. So one is peak current and other one is discharge time. Okay. So increasing the capacitance causes discharge to increase and increase both the spark current and the discharge time. Okay, right. Name some of the tool materials used in electro discharge machining. Okay, so these are the various tool materials used in electro discharge machinery. Okay, already we have discussed that in EDM the tool material is not required to be as hard as the workpiece material. It can be soft material too, but it should be a conductive material. Okay, right. So these are the some of the tool materials used in electro discharge machining. Copper, brass, alloys of zinc and tin. Next, hardened plain carbon steel. Copper tungsten, silver tungsten and tungsten. Copper graphite. What are the process parameters which affect efficiency? Okay. What are the process parameters which affect the efficiency? So first one, energy discharge. Second one, capacitance. Third one, size of workpiece. Fourth one, machine tool design. Okay, so these are the some of the process parameters which are affecting the efficiency of the electro discharge machining process. Okay, right. What is the formula for finding the energy discharge in EDM? Okay, so the formula is where W equal to discharge energy, okay, half of EIT, where E equal to potential, that is voltage in volts, and I is the current and T is the time. Okay, so half of EIT is the discharge energy. Okay, so E is the potential difference, that is voltage, I is the current and T is the time. Okay, right. Define tool wear ratio. Okay, define tool wear ratio. It is the ratio of volume of work material removed to the volume of electrode consumed. Okay, so here both tool and workpiece are okay. Both tool and workpiece material will be removed during the process. Usually, we need to remove the material from the workpiece. But the thing is that there is a possibility of some amount of material will be removed from the tool also. This is tool, this is workpiece. Okay, so it is the ratio of volume of work material removed to the volume of work material removed by the tool. Okay, volume of work material removed by volume of tool material removed. That is the tool wear ratio. Okay, right. Explain electrode wear. A crater is produced in the electrode, which is likewise dependent on the electrode material and the energy of discharge. Okay, a crater is produced in the electrode, which is likewise dependent on the electrode material and the energy of the discharge. Okay, right. What are the types of power supply circuits used in EDM? Okay, so the following are the power supply circuits used in electrode discharge machining: RC circuit, rotary impulse generator, controlled pulse, that is vacuum tube, oscillator, controlled pulse, okay, and transistor pulse circuit. Okay, so these are the various types of power supply circuits used in electrode discharge machine. Okay, right. Why the servo control system is needed in electrode discharge machine? Okay, the reason is this one. Okay, EDM requires that a constant arc gap called spark gap to be maintained between the electrode and workpiece to obtain maximum machining efficiency. Okay, therefore EDM tool incorporate some form of servo control. Okay, EDM requires that a constant arc gap to be maintained between the electrode and the workpiece to obtain maximum machining efficiency. Okay, right. Here the two, here this is the workpiece. Always there should be a constant gap. So in order to maintain this constant gap, a servo control mechanism is to be incorporated. Okay, right. During the material removal, definitely the gap would be increasing. So in order to compensate the gap, a servo motor system, okay, set up to down this tool towards the workpiece. Okay, right. Define the electrical discharge machining. Define the electrical discharge machining. EDM is the controlled erosion of electrically conductive materials by the initiation of rapid and repetitive spark discharge between the electrode tool to the cathode and work to anode, separated by a small gap kept in the path of dielectric medium. This process also called spark erosion. Okay, so EDM is the controlled erosion of electrically conductive materials by the initiation of rapid and repetitive spark discharge between the electrode tool to the cathode and work to anode, separated by small gap kept in the path of dielectric medium. This process also called spark erosion. Okay, this is electrical discharge machining or electrode discharge machining. Right. What are the factors affecting material removal rate? Okay, what are the factors affecting the material removal rate? MRR. Right. MRR, material removal rate, increases with forced circulation of dielectric fluid. Okay, MRR increases with forced circulation of right. MRR increases up to optimum value of work tool gap. After that, it drops suddenly. Okay, MRR increases up to optimum value of work tool gap. After that, it drops suddenly. MRR material removal rate is maximum when the pressure is below atmospheric pressure. Okay, so here when the pressure drops, the material removal rate would be maximum. Okay, right. How the tool materials are classified. Okay, tool or electrodes can be classified into four groups. Okay, tool or electrodes can be classified into four groups. Okay, first one is metallic electrodes, second one is non-metallic, third one combined metallic and non-metallic. Okay, fourth one metallic coating with insulators. Now let us discuss one by one. Metallic electrodes. Okay, these are brass, copper tungsten, chromium copper, aluminum tungsten, silver tungsten. Okay, right. Non-metallic graphite. Next, third one combined metallic and non-metallic. Copper graphite. Copper is the metal, graphite is the non-metal. Okay, so here some surface coatings on the copper substrate. Okay, graphite surface coating on the copper substrate. Okay, metallic coating with insulators. Copper or molded plastic and copper or ceramic. Okay, so here copper can be deployed on plastic or ceramic. Okay, what are the principal components of EDM process? Okay, so the following are the principal components of electrode discharge machining process. Power supply, dielectric system, electrodes, as usual, workpiece and tool, and this servo system for the tool field. Already we have discussed. This is tool, this is workpiece. Okay, this is gap. In order to maintain a constant gap between the workpiece and tool, in order to have the maximum efficiency and the good surface finish, a servo feed mechanism is set up here. Okay, to gradually down this tool towards the workpiece. Okay, so during machining, the material removal will be occurring. Okay, at that time the gap would be increasing. So simultaneously the tool must be come down towards the workpiece. So that it is done by the servo control mechanism. Okay, right. Next, what is the tool wear in EDM? Okay, what is the tool wear in EDM? How does tool wear occur in EDM? Okay, so partial removal of tool material from the tool surface while machining the workpiece due to discharge spark produced between the tool and the workpiece. Okay, due to the spark action, the intense heat generated near the zone melts and evaporates the material near the sparking zone. Since the tool is also within this zone, it also gets eroded. Okay, so because of this reason, the tool also will be subjected to some wear. Okay, how to minimize tool wear in EDM, electrode discharge machine? Tool wear can be minimized by using tool material that has high melting point and high thermal conductivity. Okay, also by properly configuring the tool design, tool wear can be minimized. Okay, so tool wear is a common phenomena in electrode discharge machining, but we have to select the optimum tool material in order to have the less wear. And the other point is that it should have high thermal conductivity too, along with the high melting point. Okay, so we have to select those properties materials. Identify the characteristics of an electrode material in order to serve as a good tool. Okay, it should be a good conductor of heat and electricity. It should be easily machinable to initiate at a reasonable cost. It should produce efficient material removal rates from the workpiece. It should resist the deformation during erosion process. It should exhibit low tool wear rates. Okay. So these are the characters of electrode material in order to serve as a tool in the electrode discharge machine. We can conclude. So before conclude, let us rewind one or two important points. Okay, what are the factors affecting the metal removal rate? So these are very much important points. Okay, MRR increases with forced circulation of dielectric fluid. MRR increases up to optimum value of work tool gap. After that, it drops suddenly. Okay, so MRR is maximum when the pressure is below atmospheric pressure. Okay, so with this we can conclude. Okay, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.